Hey guys, today we're going to be looking at threesome, and when I first looked at this, it kind of confused me a little bit. I thought it was a pretty complex problem, but once you break it down and you've done twosome in the past, this problem is actually not that difficult. Okay, so what exactly are we going to do here? Okay, so it says, given an integer array nums, return all the triplets, so all three numbers, such that I is not equal to j, I is not equal to k, and j is not equal to k. And nums at I, j, and k equal 0. Okay, so for instance, in this array right here, I'll bring this over here. So in this array, our intuition is like, well, we have this in an array, but what we want to do is sort it first. And so once we sort it, so this is basically sorted. And so from the sorted set, what we're going to do is this is going to be our first number, and we're looking for a triplet that adds up to 0. Okay, and so what we're going to do is we're going to say, well, 0 minus a -4 is equal to 4. And so this is the sum we are now looking for, and now we're going to reduce the problem to just a twosome, okay? And so we're looking for two numbers within the rest of the array that are going to add up to this sum, 4, okay? So we're going to look at -1, doesn't do it, -1, and then 2 doesn't do it, too small, so we're just going to continue on. And so once we find out that there's no two numbers here that complement this 4 to make 0, what we're going to do is we're going to advance the solution. So here we get to this -1, and so now we have 0 minus a -1, which is equal to 1. And we're looking for two numbers that add up to 1. Okay? And so if we look here, we're going to find a -1 here and a 2, this 2 right here. And so starting, this is going to be our high pointer. This is going to be our low pointer. And basically, actually, this is going to be our low pointer because we're already on -1. So now we're dealing with this smaller array. And so, yeah, basically that is the whole problem. So we have a high pointer, low pointer. If the number is greater than the sum, we're going to make our high pointer go towards the middle. And if it's less than the sum, we want to make our low pointer go towards the center. And hopefully they're going to converge on two numbers that add up to whatever sum we have predetermined here. Now, there is a stipulation that they have to be unique triplets. All right, so you can't have like a -1, 0, -1, and a 0, -1, -1. It doesn't work because what we want are unique sets, okay? And those would not be unique. So we could think of it as like trying to figure out all these edge cases where, how do we get rid of all these like duplicates? Or we can think a little smarter and say, well, let's not worry about the duplicates because we have data structures that actually take care of the duplicates for us. And if you think a little bit, you know, a set is really your best option, okay? So you add it to a set, and if it's already there, you know, it doesn't get added again. And if it's not there, it just adds it again, okay? So, or it just adds it, period. So, you know, using a set for this problem is actually a really good idea. So let's go ahead and look at the problem real quick and see if we can code this out a little bit or all the way. Okay, so like I was saying, what we want to do is we want to utilize a set. So we want to utilize a set. That doesn't really do anything for us, does it? And so this set is going to be a list of integers. All right. And we're just going to call this our set. And it's going to be a new hash set. All right, and then what we want to do is we want to sort that array. And so we'll just use the pre-built sort, arrays.sort. And then we're going to sort nums. Okay, and now we need to loop through the array, but we're going to use the two-pointer method. So we don't want to go to less than nums.length. We want to go to nums.length -2. So here we're just going to say for int I is equal to 0 while I is less than nums.length I++. Oops. Okay, and then here what we want to do is we want to say if I is equal to 0 or I is greater than 0 and nums at I is not equal to nums at I -1. Yeah. Okay. And so here we're going to define our low number. We're going to define our high number. And we're going to define that sum that we're looking for. So int sum is equal to 0 minus nums at I. Okay, and so what we're going to do is while these pointers do not meet, so we want these pointers to meet so that we have exhausted all the numbers, all the two-sum combinations that would complement this nums at I. So while they don't meet, we want to keep on doing something. So we're going to just do a while loop. So while low is less than high, what we're going to do is we're going to say if nums at low plus nums at high is equal to sum, we are going to add it to our set. Okay, so we're going to do set.add arrays.asList, and then in here we're going to have nums at I, nums at low, and nums at high. So nums at I, nums at low, and nums at high. So that adds it to our list, and then we're going to advance our low and our high. So we're going to say low plus plus, high plus plus. And so that's that for that if statement. And then we're going to do an else if here. Nums at low plus nums at high is greater than sum. Well, if it's greater than sum, what we want to do is we want to bring down our high number to something lower. Okay, so we want to say high minus minus. And this should be actually a high minus minus as well. So we want to bring down that high value. Okay, and so we're just going to say high minus minus. And then else, we're going to say low plus plus. All right. And then what we want to do is we want to return that list. Okay, so we're going to say list this should actually be a capital L. We're defining what it is. We're going to call this list, and we're going to say new, and we're going to pass in our set because this has a return type of a list. We're using a set, but it has a return type of a list. But we can pass in our set here into this array list, and you know, it will take care of that conversion for us. And then we just say return list. All right, let's go ahead and run this, see if I don't have any errors. Yeah, right here. So this should be the semicolon, just a typo. All right, and let's go ahead and submit. See if we get all cases. And we see, you know, that these arbitrary numbers almost, you know, what matters is it has passed, and the, you know, it's not that bad. Okay, so it looks like for this the time complexity is O of n squared because we're looping through the i's even though we don't get to the end of the list, and then we loop through the inner part of the list with our high and low pointer. Okay, so that's that, and we do have O of n. Well, the memory complexity is a little bit weird because it's not just it's a list of lists. So O of 3n. No, let's say O of n. I'm not quite sure. I would have to look at that because we're not like, yeah. So I would say O of n just to be safe, but you know, it's weird because we have a list of triplets, and so it may not always be a full list, and sometimes it could exceed the value of n. So I would have to look at that, revisit how you determine the space complexity for that. But this is a good solution, and you know, there are others out there, but I think this is the easiest to remember. So if that was interesting, if you found it useful, then like and subscribe, and you know, I will see you on our journey to complete the grind 65 or 75 problems, and on our way to becoming interview ready for some of these top companies. All right, well, I will see you later.